Go ahead, sir.
So, let's say you want to go from negative back to positive, you would just subtract one?
What you would do is you would just do the same thing, okay? So if you take, anytime you take a 2's complement, you change all the bits and you add 1. Okay, so if you want to take the 2's complement of a negative, you still do the same thing.
You still add one,
Yes.
but then would it be one higher?
No.
No, it'll still be the same thing because you're flipping the bits and there might be overflow at the end that compensates for that.
It goes both ways.
Right.
Alright.
It'll work out. So I'll prove to you it does work out.
Take your word for it.
That's okay. It might be one of those things where after we work a few examples, you can see like the intricacy of it. And I see what you mean. Like you're thinking inverse function,
Yeah.
but it's not necessarily a function because there's not a one-to-one relationship between a negative number and those 7 bits that are to the right. Okay? Because it's not really a function, it's a relation, because this could be a 1 or a 0, meaning that this number right here has a different positive and negative number when you flip it over. Okay? So it's not necessarily a functional relationship.
Yeah.
Okay? All right, other questions, guys? All right, let's try to kick a few of these out. Okay, so let's start off with a really easy one. Okay? All I want to do is add or subtract, okay, and I want to use only the 8-bit representation. Okay, so I have 89 plus 55. I'm going to change that because that answer gives us a number bigger than 128, and I don't want to deal with that because then you need another 8 bits to represent it. So if you guys would, instead of making that 89, let's make this into just 69, because that'll give us a number that's just slightly lower. Plus, who doesn't like the number 69? Bill and Ted love it, so good enough. All right. So here's the way I think about this, guys. Okay. So we start off with our sign bit. Okay. And then we have 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0. Okay. All right. I'm going to take number 69 and I'm going to take number 55. And no matter what, the sign always starts out at 0, no matter what. So if it's positive, it's 0. If it's negative, it starts at 0, no matter what. Okay. What I need to do is I need to represent 69 in binary. Okay? I think we can represent 69 in 3 bits. Okay? What 3 powers of 2, or what 3 powers of 2 could we add up to be able to get 69? Obviously 64, right? So that's 64 is that one. If we subtract 64 from 69, that leaves us with 5, right? Which is what 2 numbers in base 2?
Basically,
4 and
4
1,
and 1.
right? So we would just add 4, and we would add 1. Okay? Or, if you guys wanted to, remember the process that we just used? You would just continuously subtract, okay? I just always think to myself, what permutation gives it to me? Because we're dealing with smaller numbers, okay? But is everyone clear, like, that 64 plus 4, or sorry, 64 plus 4 is 68, and then one more is 69, and I'm just going to fill in zeros for the rest of it. Which is actually sort of the same process that we just used. Okay? Now 55 is a little bit tougher, right? So 55, I can't take 64 from that, but if I take 32 from 55, that leaves me with 23. If I take 16 from 23, that's 7. Can't take an 8. If I take 4 from 7, that's 3. If I take 2 from 3, that's 1, and that's 1. Okay? So basically, guys, what I just did was, I just did the process in my head where we converted the binary, or the decimal to the binary stuff. Okay? I just did it expediently just because I wanted to save time doing that. Is that okay with everybody, is how I did that, guys? Just do it in your head. Or, if you need to write it off to the side, that's fine too. Okay, now, here's what I'm going to go ahead and start doing some of the carry stuff, which is what you gentlemen were talking about. Because it's pretty obvious we're actually going to have several carries, right guys? So, we're going to add these numbers together. Okay, because that's what we're doing, is we're taking our binary numbers we're adding. 1 plus 1 is 10, but I don't want to write a 10 here. what I'm going to do is 1 plus 1 is 10. Okay, so see what I did there, guys? I know it's 10. I put the 0 down here, and the carry is a 1. 1 plus 0 plus 1. I can't have 2, I have 10. Okay, so does this make sense, guys? All I'm doing is I'm just adding them. And then because I can't have 2 characters in the same space, I'm carrying it over. Okay? What about 1 plus 1 plus 1 in binary? What's that, guys? 11, right, guys?
Mhm.
So we're going to have 11 here. 1 plus 1 plus 1 is 11, so I put a 1 here, and I put a 1 up there. Does that make sense to everybody, guys? We're just adding the bits. Anything bigger than 1, I'm going to have a carry. Okay, so I just carry a 1 up top. 1 plus 0 is 1.
1. Okay.
0 plus 1 is 1. 1 plus 1 is 1, or 0 plus 1 is 1. 1 plus 0 is 1. And then 0 plus 0 for the sign bit is 0. Okay? And by the way, when I say 8-bit addition, this is how the computer has to do addition. Okay? It doesn't know anything else. And then also, it goes through the logic circuits. And I showed you guys like the full adder and the half adder. Just a whole bunch of those full adders put together, okay? So, and the reason I do this is for those of you guys that are comp sci majors to get an appreciation of how hard the computer works to do this. It really is a very difficult process. Okay, so last thing a computer would do is, okay, it would spit out your answer, right? To spit it out, doesn't it convert it back into decimal, right? So let's do that, okay? So, last thing it's going to do is going to convert back. Nothing here, nothing here. Okay, this is a 2 squared for this guy. 2 to the 3rd, 2 to the 4th, 2 to the 5th, and 2 to the 6th. Okay? So, if you guys would, just go ahead and add those up. And if somebody can tell me what the answer is to that sum, or you just add the numbers and get 124, I guess.
Yeah,
Yeah, that'd probably be the cheater. That's the cheating way of doing it, but, you know.
the computer has to do it this way.
That's exactly right.
So that people don't understand.
Yeah, okay. But if you add these up, it should give us 124 in base 10. Okay? Now, this is what a computer knows in base 2. Okay? But remember, humans and computers are different. Computers think in base 2, humans think in base 10. And quite honestly, the computer's there to serve us.
So at the very beginning, or I'm sorry, at the answer, and then you added the 0 up in front of everything.
That's the sign. That's 0 plus 0, which is 0.
Oh, okay.
Okay? Okay. There we go.
Okay.
I just discounted the sign bit because I knew it was going to work out like that. So, sorry. Does that maybe help out now, sir?
Well, yeah, I just figured, I mean, I guess the sign makes more sense than I
Right.
just put like 2 to some, because
Right.
if you were to have 124, you need that extra.
Right. And by the way, you do have to have this, okay? It's 8-bit addition, so don't cheat yourself. I know like sometimes you have smaller numbers, okay? But make sure that you guys are using all 8 bits for this. Okay. So does this make sense, guys? That's what a computer has to do with positive numbers. Now what happens when we start having some negative numbers? That's where we start having to throw in that 2's complement. So let's take a look at a secondary example. Okay, so we're going to have 53 plus negative 102. So, we have our sign bit. Sign bit always starts out at 0 no matter what. We have 53, and we have our negative 102. And then we have 26, 25, 24, 23, 22, 21, 20. I'll give you guys a minute to copy it. So, no matter what, guys, if you write this on the test, you at least get a point for doing that, okay, without even doing any sort of calculations. All right. We have to somehow get 53, okay? So, to me, 53 is just 2 less than 55. So, wouldn't 53 be the exact same number here, except instead of 2 to the first is a 1, it would be a 0, right, guys? So So I just like to borrow stuff if I can. So it'd be 0, 0, 1, 1, 0, 1, 0, 1. Okay. So for 53, 0, 1, 0, 0, 0. Wait.
Yeah. 0, 0.
I'm looking at, oh, okay, 0, 0. Wait. What am I looking at? I'm looking at the 69. Okay, that's why. So, 0, 1, 1. Hey, that's not right.
I did this. You want me to tell you? 0, 0, 1, 1, 0, 1.
Oh, okay, 0, 0,
Uh-huh.
1, 1.
0.
Okay, 0, 1, 0, 1.
Uh-huh.
Yes.
I don't know, I kept starting to look at like things and started going
You're
crazy.
looking at the signs as well too.
Yep, that's what, you're right, Donnie. Okay, thank you guys. Alright. Now, 102, we're just gonna do the same thing, but we're not gonna consider the negative yet. Okay? So, I know that I need 64. Okay, so when I subtract that from 64, that's gonna be what, guys? 38. And then 38 is 64, yep. And then to get 38, that's going to be 32 and 6. So it's going to be 2 plus 4, which is 6. 6 and 32 is 38. 38 is 64. That should be 102. Is that correct, guys? Can somebody verify?
0,
Sure, why not?
1, 1, 0, 0, 1, 1, 0. Yep.
Yeah, that looks good. Okay. Yes, sir.
So, will we ever, since it is 8-bit, we won't have to deal with numbers larger than?
Correct. I will not give you numbers or answers that work out to be anything less than negative 128 or bigger than 127. Okay?
Sorry, why is the sign bit not 0?
We're going to change that in a second. Okay? Yeah, that's a good question. Okay? So we start with 0, but remember, anytime we have a negative, we're going to take the 2's complement of that. Okay? So this guy right here, since it's negative, we're going to take our 2's complement of this. Okay. So the 2's complement, we just flip the bits and then we add 1. So it's going to be 1, 0, 0, 1, 1, 0, 0, 1, and then we add the 1. Okay? So that's what a computer does. It says, okay, well, I'm going to remember that the first thing that I encountered was a negative. So instead of having a separate register for this, I'm going to go ahead and just use the 2's complement. Okay? If we add this, 1 plus 1 is 10, and then the rest of it we just carry down. Okay. So, is this okay with everyone so far? Any questions that I can answer? If for some reason you have a negative, okay, first thing you guys do is you just write out the number, okay, without the sign, then you take the 2's complement of that negative number. Okay. Now what we're going to do is we're going to take the 53 and the 2's complement of negative 102, and we're just going to add those two binary numbers together. Okay. So, I'm going to take our 53 and our negative 102. 53 was 0, 0, 1, 1, 0, 101. Negative 102, I'm going to use what's in blue here, 1001, and then 101. Let me get her guys right, sorry. And all we're going to do, guys, is we're just going to add those two together. Okay, so let's go ahead and add them. 1 plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 1, we finally get to a 10, so we're going to have to carry. 1 plus 1, another 10, so we're going to have to carry. 1 plus 0 is 1. 0 plus 1 is 1. Okay? So, that should be what the computer adds 53 and negative 102 to read. Okay? And what the computer says is, okay, well the first bit's a negative, so I can easily see that, or the first bit's a 1, so I can see the answer is going to be negative. Now, what the computer has to do though, is it has to print it out. Okay? So, before we do the last part of this, is everyone okay so far? Okay? The only difference in this problem is we just took the 2's complement of the negative, and then we added the 2's complement with the positive. okay? Now, let's say the computer wants to print this out, okay? What it's gonna have to do is, because the sign bit is a 1,
Limit reported negative.
okay, so sign bit equals 1. That means that we have to take the 2's complement of that number, okay? So if you guys ever get your answer, and you want to assume that the computer has to print that, which of course we do, okay? What we have to do is we have to take another 2's complement, and then the answer will be negative. Okay, so sign bit's 1, we're going to take one more 2's comp, and of course we're going to check this answer, right guys? I mean, there's a lot of stuff going on here, so we want to verify that the answer is correct, okay? And maybe this will help you to justify in your mind that it actually does work. Maybe not. Okay, so, guys remember, take the 2's complement, and just flip the bits. Okay, so this is our 2's. So this is going to be negative 0, 0, 1, 1, 0, 0, 0, 1. And what I'm going to do is I'm just going to tack that 1 in. Okay? So all I did there, guys, was I just took the 2's complement. I stuck a negative out in front of there. Okay? Just to remind you guys that the answer is going to be negative. So the answer is going to be negative 0, 0, 1, 1, 0, 0, 0, 1. And that's in base 2. And probably what we should do is we should check to make sure that that answer does indeed add up to, what should it add up to? Negative 50, 49? So let's hope that it does, otherwise we just wasted a whole bunch of time in
It
our
does.
lives. Okay? So, this is going to be 1. We skip 2, 4, 6, I'm sorry, 2, 4, 8, 16, and then 32. 32 plus 16 is 48. 48 plus 1